Today we're going to be looking at a very important question, and that is, can you invert a matrix? The answer is yes and no. Why? Well, the inversion of a matrix seems pretty useless at first, like why do we even want to answer this question in the first place? But only because it requires broader contextual knowledge to understand its applications, and your professors can't be bothered wasting their time explaining a fact of life. So for now, dear algebra students, you will have to accept what you are told. The only guarantee you have what you're learning is true, or what anything I'm saying is true, are proofs, which I will not be covering in this video. So if you want to prove anything, look on the internet or leave a comment and I'll do a video on a proof for a specific rule. So can you invert a matrix? The answer is layered, and you need to understand a few things before you can formulate a response to this question. Let's start with some jargon. If a matrix can be inverted, it is said to be invertible. If it can't be inverted, it is said to be non-invertible. Pretty simple. The notation. You may see that with inverses, generally, there's a -1 power up the top there. All this means is that the number you need to multiply in order to get 1. That's what that -1 stands for. I mean, look, 3 is a -1 power, and a third. Third is the number you need to multiply 3 by to get 1. So there's the notation. Now, a common mistakes, don't worry, I will summarize all of this later. Now, a common mistake a lot of linear algebra students make when they're looking into matrix inversion is that they assume that they all have inverses. They don't at all. So please remember that. Not all matrices have inverses. Now, we're going to break a rule. Let's start this video by breaking a rule. And the rule is that the order you multiply a matrix and its inverse by doesn't matter. It's a simple proof, which is, by the way, counterintuitive, given that the order you multiply matrices by does matter, but it not in the case of inverses. Because look, you say you found the inverse of A, and A is a matrix, you're getting the identity matrix either way. So although matrices share the previous fact with its algebraic relatives, being that it doesn't matter what order you multiply the inverse by, you always get 1, and in the case of matrices you get the identity matrix. Matrices have a particular property which sets it apart from algebraic inverses, and that is it can have more than one inverse. And the way to test this is just to multiply the matrix in question by another matrix, and if you get the identity matrix for different matrices, it's fine. Matrices have more than one inverse. Don't panic, you haven't done something wrong, it's completely normal. In algebra, you'll also be able to find an inverse for every non-zero number. This is not the case with matrices. Namely, if you have an SLE which has infinitely many solutions or no solutions, you will not find an inverse for the matrix you create for that SLE. This is important. So only matrices with a unique solution are invertible. That is, only matrices with a unique solution are invertible. If you remember anything from this video, remember that only matrices with a unique solution are invertible. You got it? Okay, good. So in summary, if a matrix has an inverse, it is said to be invertible. Not every matrix has an inverse. A matrix can sometimes have more than one inverse, and it doesn't matter which order you multiply a matrix and its inverse by, you will still get the identity matrix. Only matrices with which row reduce to an identity matrix will have an inverse. And yeah, that's pretty much what you need to know. Now, how do we find an inverse for a matrix? You form a super-augmented matrix. Like, yay, we found out all these characteristics, but how do we find an inverse? And you do something like this, which looks a little intimidating, but it's not that bad, because all you're doing is performing Gauss-Jordan elimination on your left matrix, and the resulting row operations will happen on your right. This matrix on your right will be your inverse for the matrix in question. Nice and simple. But before we do an example, let's involve our knowledge on row spaces and column spaces to gain some more characteristics of matrix inverses. So an n by n matrix is invertible if and only if it has a rank equal to n, which just means if you have a matrix which has 3 columns and 3 rows, or 4 columns and 4 rows, etc., etc., if the rank is equal to the number of columns and the number of rows, the matrix is invertible. There are other ways of saying this. So let A be an n by n matrix, then it will be invertible if and only if its columns are linearly independent, its rows are linearly independent, its row space is the entire vector space which it's in quotes. So if the rank is 2, then the row space will have to be r squared. The same with the column space. So if we have a full rank matrix, in other words, we have an invertible matrix, which is a pretty handy tool. So I think you're probably imagining the exam questions you're going to get. It's going to combine all of your knowledge on linear independence, row spaces, null spaces, column spaces, your operations, Gauss-Jordan elimination, and it's going to work invertible matrices in there somewhere. So I hope you're paying attention. Also, just in case your teacher really cares about how much you know when you leave, they may or may not examine you on the following rules. So I'm going to tell you them just in case, and that is, the following rule applies if you have two matrices and you find their inverse. It also follows that the inverses of them separately are the same as this. Same with if you have a matrix to some power and then you multiply it by, and you find the inverse of that, you can also find the inverse. It will be equal to the inverse of the matrix you're trying to find multiplied by some power. And if you find the inverse of a transposed matrix, interestingly enough, the inverse of the non-transposed matrix will be equal to the inverse of the matrix in question transposed. Bit of a mouthful, but it's okay. It's in pictures. Pictures are better than words in maths. So now let's do an example. Find the inverse of the following matrix and pause the video. I'm not doing it. You do it. Otherwise you're not going to learn. Okay, hopefully you pause the video and you tried it, because I'm not running through the steps. But I will run through what steps you should do. I'm not going to explicitly do the algebra. So, did you follow these steps? You put the matrix in super-augmented form. You rearranged your rows to make performing arrows more comfortable. You then didn't forget to apply your row operations on your right matrix. You got an identity matrix on your left. You got a different matrix on your right, because you've been performing the row operations. You multiplied your left matrix by your right matrix and got an identity matrix back, i.e. you checked. Because if you don't check, because you know how row operations are, they're tricky, usually slip up and make a mistake sometimes. So just check. And it's pretty easy to find. If it's the actual inverse, you just multiply the matrices together and make sure you get the identity matrix. And then you conclude that the matrix you have is indeed the inverse of L. That's quite an important one. Conclude. Always bonus marks, even if you have no clue what you're doing. Just make up, like this is what I used to do in exams when I didn't study properly. It happens. You got to learn the hard. Some of us need to learn the hard way. Just make up a bunch of stuff which looks right, and then at the end put thus said matrix is the inverse of L, and you'll get at least a mark. It might be the passing mark. Of course, study, but sometimes it happens. Now, I'm not giving you the set of steps, like I said, because I want you to learn and not copy, so go back and revise your notes if you're having difficulty, or if you didn't do any of those steps, if you had any trouble. So the inverse I got, now remember a matrix has more than one inverse, so if you have a different answer to what I got, but still get the identity matrix when you do this, your answer is right. So this is the inverse that I got. So to conclude, if a matrix has an inverse, it is said to be invertible. Not every matrix has an inverse. A matrix can sometimes have more than one inverse. It doesn't matter which order you multiply a matrix and its inverse by, you will always get the identity matrix. Only matrices which row reduced to an identity matrix will have an inverse. Now, when you do try to find an inverse, you need to perform the following steps. I'm not repeating myself. I'm sure you guys can read, but it's good to summarize what happened. And if you have a full rank matrix, we have an invertible matrix, and there are many ways to phrase that, so make sure you're familiar with the different ways to phrase this. And of course, our special rules. Final words of wisdom for the students who want to do well. Familiarity does not equal knowing. Until you can look at a problem and do it in your head, you are not fluent. So practice until this stage. You may think I'm a little crazy, but look, if everybody just think about your basic algebra, like 1 plus 1, 1 plus 2. It's a good thing you can do it in your head, and if you're going to be a professional in your field in university, you want to be able to do this in your head, and it is possible. So keep practicing until this stage. Now remember, you don't just have a time limit in exams, you have time limits everywhere. So the faster you can do a skill, the more time you will save later, mainly in moments that do count. So practice. And yes, that's the end of the video, and I hope you now have a better understanding of how to find the inverse of a matrix and when you won't be able to find one. Thanks for watching, guys.